The most distant man-made object from us is the Voyager 1 probe, which is 23.3 billion kilometers away from Earth. That's right, 23.3 billion kilometers. It's moving at 61,500 kilometers per hour. It's the fastest and most distant object humans have made. It's so far away that it has already left our solar system and is currently traveling through interstellar space. To get a better sense of this incredible distance, know that the distance between Earth and the Moon is 384,400 kilometers. The distance from Earth to the Sun, the center of our solar system, is about 149.6 million kilometers. And the distance between the Sun and the dwarf planet Pluto, which is the most distant celestial body in our solar system, is 5,922 million kilometers. The Voyager probe was launched on September 5, 1977 from the United States, aboard the Titan III rocket. Its objective was to study the planets Jupiter and Saturn and then proceed to interstellar space. On January 4, 2024, it marked 46 years, 3 months, and 30 days in operation, sending and receiving data to Earth. The probe carries with it a golden vinyl record, which contains carefully selected sounds and images from our civilization. They're meant for any extraterrestrial life that may eventually find and hear them. There are 115 images in total and various natural sounds, such as recordings of thunder, wind, ocean waves, bird songs, footsteps, heartbeats, laughter, among others. They also included greetings in 55 languages and messages from then-President Jimmy Carter. This record also includes images like mathematical definitions, a map of our solar system's location, DNA structure, sand dunes, a fertilized egg, childbirth, a family portrait, and more. If you're wondering how a probe built in the 1960s and 1970s has operated continuously for over 46 years, here's why. How do we on Earth send and receive data from something 23.3 billion kilometers away? And how does National Aeronautics and Space Administration update the probe's software? You should know the probe was designed by some of the smartest people then, including scientists, physicists, and chemists. And among them was Carl Sagan, a brilliant planetary scientist, astronomer, astrobiologist, astrophysicist, writer, and science communicator, with more than 600 scientific publications. In 2015, National Aeronautics and Space Administration advertised a software engineer position requiring some unusual skills. In the job description, the candidate was required to have advanced knowledge of Fortran and assembly, 2 programming languages from the 1940s and 1950s that most recent graduates rarely know or recognize. In fact, the position was to join a dedicated team that takes care of the Voyager probes. The probe contains 3 computers, with the main one being the computer command system, which provides sequencing and control functions. It contains fixed routines, such as command decoding, failure, and corrective routines. Antenna pointing information monitors the spacecraft's health and controls its temperature. The second computer is the attitude and articulation control subsystem, which controls the probe's orientation, keeps the high-gain antenna properly pointed at Earth, and is responsible for performing maneuvers. The third computer is the flight data subsystem, which is responsible for storing and handling all the scientific data on board and also processing the images taken by the probe. Voyager doesn't have solar panels. Instead, it has 3 radioisotope thermoelectric generators, or RTGs, which use plutonium-238 as fuel to generate power for the probe. As you can imagine, for a machine that has been operating for over 40 years, problems and malfunctions in the onboard systems are, without a doubt, inevitable. The probe has a set of small thrusters that fire short bursts to keep it, and the high-gain antenna always pointed at Earth, so the probe can not only send but also receive data. And over time, all those thrusters stopped working, and currently it's operating with the backup thrusters, which are also already showing signs of fatigue. And as time went by, more systems developed faults and stopped working. And some others, National Aeronautics and Space Administration, would send commands from Earth to intentionally shut them down, either because they were faulty, but mainly to save energy. And on February 14th, 1990, with the probe being 6 billion kilometers away from Earth, National Aeronautics and Space Administration would permanently shut down the probe's camera. Since it was on an escape trajectory from our solar system and sunlight was already quite dim, and also to save energy. But before shutting it down, National Aeronautics and Space Administration scientists sent commands for the probe to point its camera at Earth one last time and take several pictures of what it could see from that point. 60 long exposure photos were taken, and this was one of the photos taken by the probe known as the pale blue dot, which shows planet Earth as a tiny pixel, almost imperceptible in size. After this photo, the camera was turned off and its controlling software was deleted. But how exactly does National Aeronautics and Space Administration perform software updates on the Voyager probe? The Voyager's main computer has only 70 kilobytes of memory, and in fact, the probe doesn't have an operating system. That's because it would take up too much space in the memory. Instead, the data is stored in its most basic form, that is, in zeros and ones. When the probe's instruments failed, National Aeronautics and Space Administration updated its code and removed the failed system's code lines to save space but also to optimize the code. And it's always done this way. Voyager's original code was in assembly and Fortran. Assembly is a low-level programming language that we humans can interpret, and it's closer to machine language, that is, zeros and ones. Once written, the code is compiled into machine language and sent to Voyager using the Deep Space Network, a set of 3 antennas located in Canberra, Australia, in Madrid, Spain, and in California, United States, which are part of an interplanetary communication network, but also for deep space. Since Voyager is 23.3 billion kilometers away and radio signals travel at 300,000 kilometers per second, it takes about 22.5 hours for a signal sent by the probe to reach us. In other words, the probe is 22.5 light hours away from Earth, or 22.5 hours traveling at the speed of light. To transmit data to the probe, a 20 kilowatt signal is sent from here on Earth using radio waves, and it takes about 22.5 hours to reach the probe. In turn, Voyager transmits data at a power of 20 watts. However, by the time it reaches Earth, the signal is already quite weak. Actually, it doesn't matter how far the object is from Earth, but rather how sensitive the signal receiver on the antenna is to be able to pick up such weak signals. Whenever a software update is sent, it contains an interrupt code. This makes the probe's computers halt their current tasks when the signal is received and execute the new software instructions. Of course, the computers perform a check on the code to make sure there are no errors in it. And after that, a confirmation signal of the reception is sent by the probe to Earth, which takes another 22.5 hours. For example, in 1995, an update was sent so that if some systems stopped working, the probe would turn them off and on again. In 2010, one of the bits in the memory flipped, changing from 0 to 1. This caused the probe's computers to lose sync, so commands were executed 2.5 hours late. An update was sent to fix the error in the bit. And several updates were sent over the years to keep the probe working and extend its lifespan. The probe's software includes instructions for reorienting its antenna toward Earth if communication is lost, performing maneuvers periodically to maintain alignment. How does the probe know where Earth is in the vastness of space? Well, since it's not possible to use global positioning system and several other systems in space, the probe uses a navigation method based on stars. Two devices, called star trackers, are always pointed at a specific star based on its unique brightness. Anubis, the most commonly used star, is also one of the brightest. Along with these devices, a sensor on the high-gain antenna is always aimed at the sun. The probe uses this sensor to always know Earth's direction. Over the years, out of the 11 scientific instruments on board the probe, incredibly, 7 are still working, while the others have malfunctioned and stopped working or were intentionally turned off to save energy. Estimates indicate that the probe will run out of power sometime after the year 2025, when the RTGs will no longer provide enough energy for the probe's various critical systems. From then on, the probe will lose contact with Earth and will continue to travel into deep space, never to be found again,